I'd like to begin this video by telling you that this is not a perpetual motion machine. Will it run itself? Yes. Will it recharge itself? Yes. Will it recycle its own energy? Yes. Will it do that indefinitely? No. Like any other machine, eventually it will dissipate the power that's running through the circuitry through these coils. They will just, that's just what they do. They will just eventually, it'll slow down a little bit more, until it finally uses up all the power in these ultra caps. Yes, these are ultra caps. They're beautiful. They're made by Maxwell Technologies. And if anybody tries to tell you that the capacitors are the same thing as batteries, or even like batteries, they simply just don't know what they're talking about. Now, nothing against those people. They just haven't learned it yet. Everybody has to learn at some point in time. Here's a group of rechargeable batteries, except for these two right here. That's a lithium and just an alkaline. But the rest of these are rechargeable. You've got NiCad, you've got nickel metal hydride, you've got lead acid batteries, all three of these. You've got LiPo battery. All of these, including these, have one similar characteristic. They're all charged up, except for these, and store energy by chemical reaction. These do not. I mean, there's a reason these are electrostatic. These are chemically reactive. Electrostatic. Big difference. You take a lead acid battery in northern Canada, maybe a couple of days when you've got 40 degrees below zero, try to crank your car with that thing. You'd be lucky to crank it. These things would just laugh at that. 40 degrees below, 50 degrees below, who cares? They'll give you full power first time, every time. As a matter of fact, these batteries take a while to charge. These ultra caps, this whole bank, these are 350 farad ultra caps each. There's 49 of them in this grouping here. All 49 of those, with the right amount of input power, it's possible to go ahead and charge those in about 3 seconds time. Yeah, that's right, 3 seconds time. Think you're going to charge any of these in 3 seconds? Hardly. It's going to take you a long time. So these are a storage device, but that's where any similarity between these two ends. There's a reason why the automotive industry, industrial applications, transportation, renewables, like those big giant wind turbines, they all use these things. They need that super high power that these things can give off in an instant, if you need it, to change the blade pitch of those big giant wind turbines. Well, there's a reason why these people are using these things. They work. Welcome to the 21st century. I mean, even the rotors in this thing, these are not your grandfather's magnets. Those are N52 neodymiums, and there's 2 rotors in this unit. This unit is 12 inches square by 12 inches by 12 inches. It's a 12-inch cube, and except for the nice pretty blue top hat that it's wearing, and that adds another, 2.5 inches or so on the top. But essentially, what I've done here is I've taken 2 of the Quanta chargers and simply bolted them together. Just brought them together. Initially, my intention was to utilize 2 of them like I do with this side, which is the prime mover side or the motor side. And in this particular case, I've just thrown in a reed switch to react with our timing wheel here that's meant for the Hall effect sensor, and our beautiful universal controller box. That's the only thing I haven't done on this yet, because I was kind of anxious to get this video out and show you what's going on here first, because this is not a conventional pulse motor. I mean, it's very, very efficient in what it does. And the other side of this unit is not another motor, which that's what I was going to do. I was going to use them both because the near field electromagnetic transfer between this set of coils here and this first set of coils here, not the outside ones here, but just these two inside, you could actually strengthen the field by working those together, pulsing at the same time, letting the rotors pulse, the magnets as they pass the coil sets pulse at the exact same time, and pick up a lot more efficiency and RPM and torque, I'm sure too, by just doing that. So I was going to do that with the two, and I thought, I can do that anytime, or maybe I can build another one and do that. But let's try something else. So came up with another idea. This is a single phase motor here, but interesting in the way it operates. Now you can see when I spin this, let me get here where you can see all the LEDs. Okay, you can see that these two light up and then these two light up, and then back and forth and back and forth. Well, what this is it's working with the positive and negative phase of the sine wave. And when these two, let me just explain, when these two, I'll get it to stop, it's just a small space. This wheel here, there's a commutator in here, and it engages with some copper brushes. And there's little strips that are about 3/16 of an inch wide. Actually, they should be about 1/16 because I'm just getting too much. I need to make it even less. And that reed switch on the other side, by the way, let's go back over there for a second. This reed switch is very inefficient. I need the pulsing capability of adjustment of the universal controller, where I can adjust that thing down to probably about 2 or 3 milliseconds is what I need to pulse this thing. This stupid thing, I can slide this up and down. I just have a little cable tie on here and it'll slide, and that's how I can control the RPM. I get it up to close to 1,000 RPM. Depends on the power you're putting in, but I like to run it about 500. Seems to work really well. It still draws very, very little amperage. Higher voltage, that's the idea behind this anyway. But so coming back over here, all right, when these two are lit up here, this one, the contacts are closed and are allowing this capacitor bank. Okay, let me back up for a second. The capacitor bank is divided into 3 sections. This is Cap Bank 1 and Cap Bank 2, and over here is Cap Bank 3. Cap Bank 3 just runs the motor. Cap Bank 1 and 2 act as kind of a voltage doubler. Bank 1, when this one here is lit, is taking the positive peak of the sine wave and charging up Cap Bank 1, while this one here closes its contacts and allows power that has been previously charged from one cycle before in Cap Bank 2, and allows that to go to your load, whatever that may be. In this case, I've just got it ported back into itself, because I've had so many people say, well, why don't you just put the power back into itself and see how long that'll run? Well, okay, that's cool, because this sucker will run for hours. Now, if you just use the power from these caps and you didn't recycle any energy and put it back into itself, where these things are alternating, charging and unloading, charging and unloading, charging and unloading, but they're going right back into Cap Bank 3 while they're doing that. And this thing just recycles that energy over and over and over. But again, like I said, it will slowly dissipate through the motor side on the coils. But if you just use these caps and run this thing, now with this many caps, I'm operating this on a 24 volt as a 24 volt system, because I've had that requested by some too. They said, hey, can you make a 24 volt unit? We can really use that. And so it is. So these are in kind of a series parallel connection on these 3 different cap banks here. And so what happens is, when you put capacitors in series, it's not like putting batteries in series or even parallel, because these are measured in amp hours. Capacitors are measured in farads. 2 totally different ways of measuring the stored energy. So if you take and connect these in series, then however many that you've got in series has to divide into the farad amount to give you what the farads they actually are. So actually each one of these cap banks is probably only about 30 to 35 farads, where they started out individually as 350 farads each. But that's just how a capacitor works. It's different with batteries. Now, when you increase the voltage like that by putting them in series to get the voltage up, you're going to lose on your capacitance. You're going to lose on that storage. So that's how they work. So actually, so we're talking about only 30 farads of storage for this whole bank at the voltage that you want, because each one of these is about 25, 26 volts, so it'll charge up a 24-volt system, which is the intention. I didn't build this with the sole intention of just having a machine that will run and charge itself. Though that is very cool, that is not the intention. The intention is to use both the output right here from the motor side, which you can do with our kits right now, and combine that with the power from the sine wave peak generator side. And again, this is the positive, like I was telling you. It works on the positive of the peak, and then when it comes down and these light up down here, that is the negative peak of your sine. And it's doing the same thing, and they just go back and forth and back and forth. Load, unload, or charge and unload, and charge, unload, charge, unload, charge, unload for both these banks. So that's how that's functioning. I call this thing the Q2 simply because, like I said before, I just brought two of the Quanta chargers together. But you can see now that each of them are unique in the operation of what they do, from the highly efficient motor side to a sine wave peak generator on the other side, because the idea of that is you want this thing, if it's running at 500 RPM, when you engage this with N52 Neos and these big coils, if it was just a standard generator, this thing would come to a stop. It wouldn't rotate. But by taking off that peak power off the sine wave from the bottom and the top of the wave, this thing doesn't even, it won't even lug it. If it slows it down at all, maybe it's 5 RPM or 10 RPM. Something not even hardly perceivable except with laser tag. And then you can see. Now be patient. I'm going to start this thing so you can see what it's going to do.